Hello everyone, my name is Eniola and I will be taking you through the hands-on process of how to create an ERC721 token. Basically, an ERC721 token is a non-fungible token, unlike the ERC20 token. I mean, we have other types of tokens, right? We have the ERC20 token, which is a token for the fungible asset. We have the ERC721, which is a token for the non-fungible asset. We have the ELC 777, ELC 1155, and you know various other tokens like that. But for the purpose of this lecture, we'll be talking about ELC 721. ELC 721 is a non-fungible token, like I mentioned earlier. It's the token that is used to make NFTs. Now, the process of creating an ARC721 token is not actually hard because it involves a smart contract. Because with NFTs bringing blockchain to the public eye, so this is like a perfect opportunity to learn more about it. Learn how to deploy your own ARC721 token on the Ethereum blockchain. For the purpose of this course, I'll be taking you through two different methods of creating this token. The first method is like the simple, basic, and straightforward way of creating the token. And the second method is more advanced because it depends on the size of the project that you're building, or you just want to know how it looks like or feels like to create the token. So we'll be going through both methods together. So the first method will only involve using the Open Zeppelin's contract and remix. That's what the first method will be taking us through. And then the second method, we'll be making use of MetaMask, we'll be making use of Solidity programming language, we'll be making use of ADAT and IPFS, which is a decentralized file storage system. And then we'll also be making use of Alchemy. You would understand what all these tools, do along the way. All right, so the first thing we'll be doing is going to the Open Zeppelin's documentation to find our contract for the ERC721 token. Basically, Open Zeppelins help us to create, or what part of what Open Zeppelin does is to create a standard for creating these tokens because their codes are mostly audited, so it's kind of safer to use their code. There are literally other standards of creating tokens, but Open Zeppelin is widely adopted, and I would advise that you use it. All right, in the contracts tab here, we have on the list of tokens that, like I mentioned earlier, and we'll be focusing on the ERC721 token. If you want to learn more about it, you can, read more about it here. All right, so the first place we'll be going to is the wizard because the wizard, helps us to have an interactive interface of, how the ERC721 coding, sorry, ERC721 token, how it works. So the first thing here we have, clicking on the ERC721 tab, is we are going to state the name of our token. Let's name it Block Games NFT. And then let's give it a symbol called BGN, right? All right, so the next thing we'll be doing is to be checking the mint table function. This mint table function will actually enable us to mint a token. If we are going to be also checking the auto increment ID, that means maybe we are trying to um, create various copies of a particular token. You get it. Let's say you have a particular NFT art and you want to make like a mint about maybe 5 copies of it. Yes. So this is where the auto increment ID comes in because yeah, it increments the token ID. Of course, each art will have a unique ID on its own. So these are the basic features that we actually need to create our ERC721 token. So the next thing we'll be doing is to copy this code. This copy to clipboard button doesn't work, so the thing I will do here is just uh, copy directly and then open Remix on my browser here. All right. Okay, so we are going to create a file and let's name it block games. Dot so yeah. So I'm going to paste my code here, and we are going to wait for it to compile. Okay, so before we actually, yeah, it has compiled successfully here. Okay, so just to explain what each line of code does, right? So the first line of code is explaining the license identifier for our code, which in this case is the MIT. That means the code can be shared and distributed, and used. If you want to learn more about license, you can check on Open Zeppelin's documentation. I think they actually have a tab on, these licenses. And then the second line of code is where we have our Solidity version declared. Then we also have imported some libraries from the Open Zeppelin's contract. The first one we imported was the erc721 contract code. The second one we are importing is the access enable contract code, which is going to help us limit or define a particular access, maybe to a function or even to our contract. Then the third import we are making is for the counters. Of course, it's meant to, we already checked the auto increment token ID feature, so it's going to be really helpful and handy in this case. All right, so I think this one is well explanatory. Contract block games. Block games is the name of our contract. And yes, it is inheriting the ERC721, as we have imported it here, it is inheriting it. And it's also inheriting the enable contract. And we are using counters here. All right, so yeah, we have our constructor, which is defining our NFT name and the NFT ticker or symbol. We also have a function called safe mint here. This safe mint is responsible for minting our NFT and assigning a token ID to it. All right, so straight to deployment. I will be deploying locally since we still have a long way to go in 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 the broader method. That's in the second method we are doing. Remember, I mentioned that we are going to look through two different methods of creating this token. All right, so in this case, what we're going to do is deploy our blog games or so, and I don't know if this is disturbing, but I think they should be able to collapse. Okay, all right, collapsed. All right, so yeah, it shows that our contract has deployed successfully here, and for us to actually confirm that what we are doing is right, we have to confirm that okay, calling the owner function shows that I am the owner of this contract, just like it is showing in my account here. Or even if I'm using MetaMask, it's going to be showing my MetaMask address. That is if I'm using the injected Web3. But since we are just deploying locally on Remix, yeah, this is my address. And I've been assigned like 100 Ether. And yes, I have 99.9 right here now because, transaction fee has been deducted when I deployed my contract. So the next function we'll be calling is the name function call because, of course, we already defined it in the constructor, right? So when we call it, it's going to show us the block game NFT name as, name of our NFT collection. All right. So the next thing we are going to do is save mint, right? So we know we already have a save mint function here, and all we have to do now is mint, you know, an NFT into my address. Let's say I'm using MetaMask for example, so it's going to mint it into my wallet. So yeah, this is my local wallet address, right? So it's minting it into my wallet. Nevertheless, okay. So I'm going to run this transaction, and it shows that it is successful. Now, how do we actually confirm that? Yes, so it has really, 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 really minted. All right, so let me shift this up a bit. All right. So you see that we have this is my contract address right here, right? Because it was minted to this address from address 0, right? And it was minted to my address, which is my wallet address. And then my token ID here is 0. Quite right. That means I've only minted once, right? And yeah. So if I'm minting again twice, let's see. Okay, see now my token ID is 1, right? So that means I have minted NFTs that has a token ID 0 and also a token ID 1. Let's just mint one more time because we have to keep calling the mint function, for as many times as we want. All it has to do is just to increment the token ID value. Okay, so when we check again, our token ID is 2. Okay, so the next thing we will do now is check the balance of, right? So we are going to be calling the balance of method, still using our my wallet address that I used in the safe mint, right? So if I call it, yeah, it shows that I literally have like 3 NFTs minted. Remember that we call the safe mint function like 3 times and they all have token ID 0, 1, and 2. And it shows in the balance of here that I have minted, 3 NFTs. You get. All right. So that would be all for now. That would be all for now, actually. Of course, you can play around every other function. It depends on, whatever it is that you want to achieve. Take, for example, this owner of now, I can check that, okay, we have token ID 0, 1, and 2, right? We verify that. So I want to check that, okay, who owns the token ID 1 and it's supposed to generate my address for me. Yeah, we just did that. Okay. So you can play around your functions and, depends on whatever it is, whatever information or data you're trying to get. Now, Remix is actually a lazy way, quote unquote, of interacting with your smart contract. The best thing to do is actually use a framework, that interact directly with your front end and interact with an Ethereum clients, and then of course you can run your own nodes. And I mean, Remix can be funny sometimes. It could just hang and your code can disappear. So be wary of using Remix. All right, so this is the end of the first method that we talked on, right? So the next thing we will be doing is we are going to be using adapt in this case. Alchemy.